I want to find the volume of the solid generated in this area, so I want to sort of sketch what it looks like. If I sketch it, I'm going from 0 to pi over 2, so here's pi over 2, and cosine of 0 is 1, cosine of x over 2 at pi over 2 is pi over 4 radical 2 over 2, so my cosine looks like that. And my sine at 0 is 0, and it also goes up here. So here's what I'm looking at. And this is my cosine, and this is my sine function. So I need to figure out what my big R and my little r are, because I'm revolving it around the x-axis. So my big R is going to be cosine of x over 2, and my little r is going to be sine of x over 2. That means that r squared is cosine squared of x over 2, and little r squared is sine squared of x over 2. So I have my volume, where my r squared minus big R squared minus little r squared is cosine squared of x over 2 minus sine squared of x over 2. I'm going to have to use that rule, so I'm going to use the double angle. Now, so if theta is x over 2, then 2 theta is x. So this cosine squared is the same as 1 plus cosine of 2 theta, or x, over 2. And sine squared is 1 minus cosine of x over 2. If I combine these, it turns out the 1/2s go away, and what I really have is the volume is the integral pi, the integral from 0 to pi over 2 of cosine x over 2 plus cosine x over 2, are just plain old cosine x. Right, because it's 1/2 minus 1/2, because this becomes a, if I change that, that becomes a minus, that becomes a plus. So I have 1/2 cosine x, 1/2 cosine x, the whole cosine x. So I can integrate that, and that's just sine x. So I have pi times sine x from 0 to pi over 2, which is pi times the sine of pi over 2 minus the sine of 0, and that just gives me a volume of